Hello. I wanted to take a look at adding fractions with hard denominators. And I guess this could be adding and subtracting fractions with hard denominators, but we'll just do adding. We've talked about adding fractions with not so hard denominators. For example, maybe we did like 7/12 plus 3/10. We would say, okay, well, they both are even, so they both share a common factor of 2, so we're probably not going to just multiply them together. There's something smaller that both of them go into. But what is it? And so what we did was we said, let's start with the larger denominator, and let's just skip counting until we find one that 10 also goes into. And so we would say, I'm going to write them down, although we don't always do this. We would say 12, 24, 36, 48, 60, 60, there it is. That's the one that both 10 and 12 go into. And then we would say, well, 60 is going to be the common denominator. So how many times does 12 go into 60? Well, it's the fifth one we got to when we skip counted, so this must be times 5. And then we could do 7 times 5 gives us 35, and of course we know 12 times 5 is going to give us that 60 that we want. And then we would repeat that process with 10. We would say, how many times does 10 go into 60? Again, that is an easy denominator. So we would say, well, that's pretty clear. It's 6. And then we would do times 6 in the numerator. Again, we always want this to be equal to 1 or a whole. And so that's why we do numerator and denominator the same. Then 3 times 6 is 18. And now we're ready to add, or in the case of subtraction, we'd be ready to subtract, and we would say 35/60ths plus 18/60ths. Again, this is acting like a noun, so we have 35 of this thing and 18 of the exact same thing. So we would say 35 plus 18, well, 5 plus 8 is going to give us a 13, and then we would carry that 1. 1 plus 3 is 4 plus 1 is 5, and so we would get 53/60ths. And at this point, we would want to check to make sure that we can't reduce this, or if it were an improper fraction, we would want to change it to a mixed number. But I can see that, well, let's see. The factors of 60 would be 2, 3, 5, and 10, 6, but none of those go into this. We could use our divisibility rules to check that it's not divisible by 2 because it's odd. It's not divisible by 3 because the sum of 5 and 3 is 8, and 3 does not go into 8. Since it's not divisible by 3, it can't be divisible by 6. It's not divisible by 5 because it doesn't end in a 5 or a 0, and same for 10. So this would be our final answer. Okay? But then the bigger question is, okay, what happens when we get to something like 19/42 plus 17/48, right? If we were to use the strategy that we did up here, we would be writing A for a long time to get to a denominator that both 42 and 48 go into. Second of all, I don't know my 48s. I don't know my 42, so would I even recognize a multiple of 42 in that list of multiples of 48? All right, so we need a different strategy that we can work with when we end up with numbers that are big like this. Again, you could always multiply them together, but that's going to make it harder for you to simplify in the end, so sometimes it might make it a little bit easier to do an extra bit of work here. All right, so we're going to do that by prime factorization. So I'm going to write 42 and 48, and I'm going to find their prime factors. All right, again, we've done this already. So I just find two things that multiply to 42, so I'm going to go with 6 and 7. You might have thought of 2 times 21. It doesn't matter. In the end, it will give you the same thing. All right, and 6 is 2 times 3. And I've just gotten to all primes. I'm going to circle them so I don't lose any of them within my work. And then for 48, I'm going to have, let's say we go 6 times 8. 6 is 2 times 3. Those are both primes. 8 is 2 times 4. 2 is a prime, and 4 is 2 times 2. All right, so I'm going to write these out, and again, this is the way we've done it in class. I'm going to write 42 is 2 I'm going to write mine over further here. Actually, let me write the 48 first, and you'll see why in a second. So I have 4 2s and a 3, so I'm going to write 2 times 2 times 2 times 2 times 3. And then I like to stack these up when I write them, so instead of starting over here, I'm going to write 2 times 3 times 7, so that they align. Right, and again, as we've done in class, you're going to circle all the ones that they have in common and bring them down. Right, so I'm going to bring down the 2. I'm going to bring down the 3. Right, if we stopped here, this would be the greatest common factor that both of them share, but we don't want the greatest common factor. We want the least common multiple. For the least common multiple, we bring down even those things that they don't have in common. So I'm going to bring down all these 2s, and I'm going to bring down this 7. And that is the least common multiple. And in our case, we're also going to call it the least common denominator because it's going to become, whoops, not LDD, LCD, because that's going to become the denominator of our new fractions. All right, so we need to multiply that out. We know, well, let's see. This part, the 4 2s and the 3, we know from this, 1, 2, 3, 4 2s and a 3, this part is 48. And then we just have this extra 7. All right, so let me do that. 48 times 7. 7 times 8 is 56. That's 28, 29, 30, 31, 32, 33. So our least common denominator is 336. Whew, that would have been a lot of skip counting if we had to do that. All right, don't erase this. If you're doing it on your whiteboard, do not erase this part because we're going to use it 3 other times. All right, so I'm just going to do what we did up here and set this up. Then I need a 336 as our common denominator. All right, again, this is the part that's going to be challenging if we've just done, if we have erased this already. I need to know how many times 42 goes into 336. Now you could divide, but that would take a long time. So let's go back to our least common multiple. And we're going to look at what the 42 contributed to the least common denominator. It contributed a 2, a 3, and a 7. What it did not contribute were these 3 2s right here, right? So what 336 has that 42 does not is an extra 3 2s, or an 8. All right, so then I can go back up in here and say, oh, well then this must need an 8 in order to multiply together to give me 336. All right, let's come back in just a minute and do that multiplication here, but let's try that again with 48. Again, I look and I say, well, what did 48 contribute to the least common denominator of 336? Well, it contributed 4 2s and a 3. It contributed all this right here. So what did it not contribute? It didn't contribute a 7. And therefore, this has to be a 7 right here. Okay, now let's do that multiplying. I have to do 19 times 8. I'm going to come up here just so I can use this space down here later. 19 times 8. 9 times 8 is 72. 8 times 1 is 8 plus 7 is 15. So this is going to be 152. And then 17 times 7. 7 times 7 is 49. 7 times 1 is 7. Plus 4 is 11. So this has to be 119. Right, and just again, as we did before, we're just going to add the numerators because these denominators are acting like a noun, like 152 puppies plus 119 puppies. We just add the numerators because that's telling us how many we have, and the 336 is telling us what we have. All right, so 2 plus 9 is 11. 5 plus 1 is 6 plus 1 is 7, and 1 plus 1 is 2 over 336. Again, this is the part that might feel overwhelming for you to look at that and say, how am I going to reduce that? It's going to take so long to find the common factors. But it's not, because look, again, we know what all the factors of 336 are. If there's going to be any canceling or reducing that we can do, it has to be something that the 271 and the 336 have in common. And so our only choices are the ones that 336 already has. So let's go through and see if they share any common factors. Again, we're looking for a 2. It might be multiple 2s because 336 has 4 of them. But at least let's start with A2, A3, and A7. And if they don't have any of them in common, then we're done, we're reduced. Okay, so let's see, does 271 have a 2 in it? Well, if you remember our divisibility rule, it has to end in an even number if 2 is a factor. And since 1 is odd, it does not have a 2. Right, so it's not going to have any number of 2s. If it doesn't even have 1, it won't have more than 1. All right, let's look at 3. What was the rule for 3? All right, we take all the digits, the 2, the 7, and the 1, and we add them together. 2 plus 7 is 9, plus 1 is 10. If 3 goes into the sum, 10, then 3 also goes into 271. But 3 does not go into 10, so 3 does not go into 271. So no to 3. So our final one is 7. Our rule for 7 we just learned this year. We have to take the digit in the ones place and double it and subtract it from whatever is left. So we're going to take the 27, the part that isn't the ones digit, and then from that we'll subtract double the ones digit. So we're going to do minus 1 times 2, which is 2. 7 minus 2 is 5. 2 minus nothing is 2. If 7 goes into this, then 7 goes into 271. 7 does not go into 25, so 7 does not go into 271. So this right here is the fully simplified answer. All right, hope that helps if you're struggling with adding fractions with hard denominators. Bye.